So, in the 7th lecture, so I have discussed about the cone penetration test, then pressure meter test, then the dilatometer test. Then I have solved one problem on the dilatometer test, that how to use the dilatometer test data to determine the soil properties. Now, here I will solve one or two problems to show that how we can use the other test data to determine the soil properties. So, and then I will discuss about the type of sampler that we generally use to collect the soil sample from the field. So, and so first if I use a typical example to solve that our cone penetration test data, that so suppose if for a clay soil, undrained cohesion of the soil can be determined is by QC minus sigma V divided by your NK, and NK value. So, if a particular test that our QC value is given 5000 kilonewton per meter square, and sigma V we have to calculate, suppose the unit weight of the soil is 18 kilonewton per meter square, and we have a depth of say 5 meter. So, here this is, remember that this is the total stress. So, you have to calculate 18 into 5. So, that is 90 kilonewton per meter square. So, we can write this is 5000 minus 90 and NK value is taken as 20. So, if I take these things, so the undrained cohesion of the soil 45.5 kilonewton. So, again QC is QC minus sigma V NK. So, QC value is given 5000 kilonewton meter square, sigma V we have calculated 90 kilonewton meter square, NK is taken 20. So, if I put these values, then it will become to 45.5 kilonewton meter square. So, this is the undrained cohesion of the soil. So, automatically if QC value increases, that means soil has less strength. So, automatically Cu value will also decrease. So, QC value, if QC value decreases for the less strength, so automatically Cu value will also decrease. And then if I, this is the one example for the cone penetration test or SCPT test. Now, another example I can give you for the pressure meter test. So, if I gave you another example, that is for the pressure meter test. So, values are given that the capital V0 is, as I mentioned, 535 kilonewton per meter square, sorry, this is centimeter square, and P0, that is the stress, is 40 kilonewton meter square. P0 is the pressure, corresponding V0 is 44 centimeter square. Then PF is measured as 3 to 4 kilonewton per meter square, and Vf is equal to 178 centimeter square, and mu is taken as 0.5. So, we have to calculate the pressure meter modulus. that is EP is 1 plus mu V0 capital V0 plus small vm into del P divided by del V. So, del P is the Pf minus P0. So, that is 324 minus 40. So, that is 284 kilonewton per meter square. Del V is the Vf minus V0 and this Vf is 178 minus 44. So, that is equal to 134 centimeter square, and this capital small v m is equal to Vf plus V0 divided by 2. So, that is equal to 178 plus 44 divided by 2, that is equal to 111 centimeter square. So, finally, EP value is equal to 1 plus 0.5 into capital V is 535, then Vm is 111, then del P is 284 divided by 134, and so that value will be equal to 4107.4, that is kilonewton per meter square, because this centimeter will cancel and this is the kilonewton per meter square. So, this value will be 4107.4 kilonewton per meter square. So, this way we can calculate the EP, and then if you have the other data also, we can calculate the other soil properties. So, next test that I will discuss about the vein shear test. So, this is the last one of the all in situ test that I have discussed. So, this is suitable for the clays, mainly for the soft clays, and here we insert the this vein into the soil up to the required depth. So, here borehole is required, and then we apply a torque, and this torque is measured, and the based on that we calculate the undrained shear strength of the soil Cu. So, this is the T is the torque applied, Cu is the undrained shear strength of the soil or undrained cohesion of the soil, and D is the diameter of the soil cylinder sheared, and H is the height of the vein. So, if you look at these things, so this is the diameter of the vein, and this is the height of the vein. So, and so if I generally H is approximately 2 times of the diameter. So, if I know that D, if I know the H, and if I know the measured torque that we are applying into the soil, so we can get undrained cohesion of the soil by using this expression. Now, if I now summarize all the tests that I have discussed. So, I have discussed the SPT, I have discussed the vein shear test, I have discussed the PMT pressure meter test, and this is the CPT or the cone penetration test, and DMT dilatometer test. So, here we can see for the first 3 SPT and then the vein shear test and then the pressure meter test, these are conducted into the boreholes, and whether CPT and DMT, these are pushed into the soil, and this there the borehole is not required. So, here any cone penetration test and DMT boreholes are not required, but other 3 these boreholes are required. Here we are apply a torque, here we apply the hammer blow, here we apply the pressure and volumetric expansion is measured, here we push it or we apply the blows, and here again this is the expansion is done for a thin membrane which is pushed into the soil with this setup. So, these are the common in situ testing device that we use in the field to determine the soil properties. So, next one we will discuss about the type of sampler, because as I discuss about in the boring part also, that all the process that we are using the auger boring, we are using shell and auger to construct the borehole. Okay? And it is also mentioned that whenever the sample is required, we collect the soil sample from different depth depending upon our requirement. So, there is a two ways we can collect the soil sample, one by boring, either it is a auger boring or the wash boring or the shell and auger or the other boring techniques. So, we can collect the soil sample in that form also during the boring. So, that will give you the highly disturbed soil sample, and other ways if required we can collect soil sample using the sampler tube. So, these are there are different types of sampler tube by which we can collect the soil sample. So, today I will discuss about these sampler tubes and what about the other disturbed and undisturbed soil sample. So, that means there are two types of soil samples, either the disturbed soil sample or the undisturbed soil sample. So, now the disturbed soil sample is that in which the natural structure of soil gets modified partly or fully during the sampling, and in the undisturbed sample is that in which natural structure and other physical properties remain preserved. So, but as I mentioned, when during the disturbed soil sample collection, that we also use this disturbed soil sample to determine the soil properties. Now, what are the properties where we use the disturbed soil sample and where we use the undisturbed soil sample? So, disturbed soil sample or the representative soil sample generally be used for grain size distribution analysis, determination of liquid limit, plastic limit or the Atterberg limits, specific gravity of the solids, then organic content determination or the, so again this for the soil classification. And but as I mentioned, the major properties of the foundation design are the strength property of the soil and the drainage property of the soil. So, that is why this drainage property and in terms of the consolidation properties, because when you calculate the bearing capacity, we need the shear strength properties. So, when you calculate the settlement for the foundation, we need the consolidation properties. So, these tests where the use of undisturbed soil sample must, because other here we cannot use the disturbed soil sample. So, these tests are consolidation test, hydraulic conductivity test and shear strength test. So, shear strength test, as I have discussed, we can do it by the triaxial, we can do it by unconfined compression test or by direct shear test. So, where for the shear strength calculation the use of undisturbed soil sample is must, in addition to the consolidation test and the hydraulic conductivity test, because consolidation test will get the value of Cc, that the compression index. So, that Cc we will use for our settlement calculation. So, that is why this test where we have to use the undisturbed soil sample. So, now what are the criteria for the collection of undisturbed soil sample? So, required for triaxial consolidation test in the lab and good quality sample recovery necessary is area ratio should be less than 10%. So, now what is area ratio? So, this is a typical sampler tube. This is basically a hollow cylinder where it is a outer diameter or the internal diameter. So, area ratio is the outer diameter square minus internal diameter square divided by internal diameter square. So, this area ratio should be less than or around 10%, so that we can get good quality undisturbed soil sample. So, it is expected that if the wall thickness is more, so we have the greater disturbance, and if the wall thickness is less, so we have the less disturbance. And then once we collect the undisturbed soil sample, we have to take care during the transportation and during the testing in the lab or during the handle of all this process of this sample. So, next one is the sampler disturbance, IS code also recommend some additional guidelines. So, this is a particular sampler tube. In sampler tube, in front of that a cutting edge is attached. So, this cutting edge basically help to penetrate this sampler tube into the soil. So, I have already shown you in the during the SPT test that a split put sampler is attached in the front of the rod. So, on the top bottom of the rod. So, that sampler tube is penetrated into the ground by blows. So, here also, so this is the here the cutting edge is there. So, that will help to penetrate the soil sample into the penetrate the sampler tube into the soil. So, and you are applying the blows. So, depending upon that there are other criteria to collect the undisturbed soil sample, that if the this is the D1 is the internal diameter of the cutting edge, D2 is the outside diameter of the cutting edge, and D3 is the internal diameter of the sampler tube, and D4 is the outer diameter of the sampler tube. Then the C0 we can get by these expression. Area ratio, as I mentioned, that area ratio will be D2 square. Here as there is a cutting edge is attached. So, we use these diameters because these are the diameters, but if the other things we have mentioned that if there is no cutting edge, only the sampler tube, then basically the diameter of this cutting edge we are considering as the area ratio here, and Ci is we can get by using these expression. So, these are the conditions that for which if we satisfy these conditions, then we can get a good undisturbed soil sample. So, this is the range between of the Ci, C0, and area ratio should be not greater than 20% for steep formation, or for the soft formation area ratio should be less than 10%. So, it is less than 10% for soft soil, or around not should not be greater than 20% for the steep soil. So, it should be around 10 to 20% for the steep formation, and soft clay it is less than 10. So, now when we collect the soil sample, so there is a recovery also. So, how we can get the recovery? So, with this recovery ratio LR. So, this recovery ratio is actual length of the recovered soil and theoretical length of the recovered soil. So, this is the actual theoretical length of the tube, and then how much length of the soil sample you have collected inside the tube. So, that is the actual length of the recovered soil, and then if it is 1 which indicates a good recovery, if it is less than 1 which indicate the soil is compressed, and if it is greater than 1 which indicates the soil has swelled. So, that means for the good recovery the recovery ratio should be 1, otherwise it will indicate whether it is being compressed or swelled depending upon the recovery ratio. And then, so that means there are two types of samplers. So, these are samplers are thick wall sampler or split pun sampler. So, this sampler tube, thick wall sampler or split pun sampler, this tube is used for the SPT to collect the soil sample. So, and this another one is the thin-in-one samplers or shell by tubes. So, now the split pun sampler, its drive shoe attached to the lower and serve as a cutting edge. So, as I mentioned, there is a cutting edge which is attached into the sampler, and then sample head may be screwed at the upper end of the split pun, and this is the standard split pun sampler diameter is 35 millimeter internal and 50.8 millimeter external diameter. So, this is important. So, we have a 35 millimeter internal diameter of this sampler, and the 50.8 millimeter is the external diameter of the split pun sampler. So, this is the other description that I have given, that the sampler is lowered to the bottom of the borehole attaching a drill rod, and the sample is driven drawing by forcing into the soil with hammer blow. So, that is done for the SPT. So, we attach the sampler tube with a rod and then we lowered it to the required depth and then apply the blows, and sampler tubes is penetrated into the soil and the soil sample is collected through the sampler tubes. And then the assembly of the sampler then extracted from the hole, and the cutting edge or the coupling at the top of the top are unscrewed. So, I will show what is coupling, and then the two halves of the barrels are separated and sample is exposed and we collect the sample. So, I have shown this during the SPT, that how the soil samples is a sampler tube is removed from the soil and the cutting edge is removed, and then we have there is a two halves, and inside there will be a soil sample, and samples are generally taken in interval. So, 1.5 meters, so not more than 1.5 meters. So, as I mentioned during the SPT. So, this is the typical sampler Speedpoon sampler tube. As I mentioned, there is a two halves and this is the soil sample. This is the soil sample and these are the others arrangement, though this is the, as I mentioned, this is the cutting edge where the internal diameter is 34.5 millimeter or roughly 35 millimeter, and this is actually the outer this one is the outer diameter of this cutting edge. So, this is 50.8 and this is 35 millimeter, and this is total is the coupling, where is this is the drilling rod which is attached with this head. So, there is a water port and there is a one way valve is also attached here, and there is a pin. So, these are the total assembly of this Speedpoon sampler, and then this is the figure. And so, as I mentioned, so what will be the area ratio, because internal diameter is 34.9 or 35 millimeter or external diameter is 50.8 millimeter. So, the area ratio is 112%, which is very high with the as compared to the required area ratio to collect a undisturbed soil sample. So, if I use the Speedpoon sampler, the soil sample that is collected which is disturbed soil sample. So, hence the samples are highly disturbed, because your area ratio which is around 10% for a good for collection of a good undisturbed sample is 10%, then here it is 112%. So, which is a disturbed soil sample, it is the, and then when we use it for the sand, then we use spring core catcher. So, this is the spring core catcher, this is attached to collect the soil sample for sand. So, but all the cases the soil sample which is collected by using the Speedpoon sampler is disturbed soil sample. So, next one, the thin wall sampler. So, as I mentioned, if the thickness increases, the disturbance will increase. So, here the thickness will reduce. So, that means here this is the two types of sampler with in terms of diameter. So, if the one is 58.8 millimeter outside diameter and this 76.3 outside diameter. Now, the sampler with a 50.8 millimeter outside diameter has the inside diameter is about 47.63 millimeter. So, the inside diameter is 47.63 millimeter, outside diameter is 50.8 millimeter. So, the area ratio is 13.75%. So, which is close to the 10%. So, we can get undisturbed soil sample if I use the thin wall sampler to collect the soil. So, now this is the typical photographs of a thin wall sampler. This is where the thickness is less and area ratio is also around 10%. So, we will get a good undisturbed soil sample. The next one that I will discuss about that how many boreholes we will decide for a particular proposed building or particular site. So, now this number of boreholes, that depending upon the type and size of the project, budget of the site investigation and the soil variability. So, this is very important. So, now if we find that for a particular borehole there is a particular 2 boreholes or 2-3 boreholes data, there is a huge variation of the soil sample. So, then we have to increase the number of boreholes in between those boreholes in such cases. So, that depends on the variation of the soil property, soil in different number of boreholes. The budget of the site, if your budget is more, you can use more boreholes, and if the typical size of the project and type, if the type and the size of the project, that also indicates that how much, what is the number of boreholes you will consider. So, another is you locate at the boreholes where you are expecting the more loads are coming in a particular building. So, then the spacing of the boreholes, this is a typical example is given, that for the multi-storied building the spacing between boreholes is 10 to 30, one-story industrial plants 20 to 60 meter, for highways, residential and dam or dikes, these are the spacings given. Then for the minimum depth of the, so one is the spacing of the boreholes, another is the depth, how much depth will go to collect the soil sample in a borehole. So, and so that means this is the typical for a building width of 30.5 meter, that the number of stories, if it is 1, the borehole depth will be 3.5 meter. If it is 2, it is 6 meter, 3, 10 meter, 4, 16 meter and 5, 24 meter. So, these are the approximate values are given. So, it is suggested by Sowers and Sowers in 1970. So, but our IS code also recommends the depth of boreholes. So, this is the IS code recommendation, IS code 1892 1979, where if the footing is isolated footing or the raft foundation. So, later on I will discuss what is isolated footing, what is raft. So, but here these are some guidelines are given. So, for right now we just see those guidelines. So, later on I will discuss these, what is raft, what is the isolated spread footing, what is strip footing, all these things. So, here for the isolated spread footing or the raft, so this the depth of the borehole should be 1.5 times the width of the foundation. So, if your foundation width, whether it is spread footing, isolated or raft, is B, then depth of the borehole will be 1.5 times of the B as per the IS code. So, these about the depth of the borehole. So, when we are talking about the raft, and we will mainly discuss about the raft, or we will discuss about the isolated footing, then that the borehole requirement is 1.5 times of the B, minimum borehole requirement. So, next one, that how we will identify the water table location, that is also very important. So, that the correct indication of general groundwater level is found by allowing the water in a borehole to reach the equilibrium condition. So, that means we construct a borehole and we fill it with the water, and then after a certain time, depending upon the type of the soil, the water level will come into equilibrium. So, it gets very quickly within few hours if it is a sandy soil. If it is a clay soil, it will take many days for this purpose. And for the clay soil, the standpipes or the piezometer are used in clay or seal to determine the water table location. So, these are the, so this class I am finishing this class with that note that we have discussed of all the penetration test and the other in situ test, and we have compared them, and we have discussed how we will get the different properties by using the different methodology described in different in situ test, and then we discuss about the various samplers by which we can collect the soil sample, whether it is a disturbed or undisturbed, which sampler tube we will use to collect the soil disturbed sample and the undisturbed sample, where we will use the undisturbed sample to determine the soil property, and where we will use the disturbed sample to determine the soil properties. and then what would be the spacing and the depth of the borehole, and how we will locate the water table location. So, in the next class I will discuss the last topic of this soil exploration, that is the geophysical exploration, and in the next 2 classes I will discuss about this geophysical exploration. Thank you.